We'll give everyone a few minutes to get settled and for more to join before we get started. Hello everyone, welcome to today's webinar, Reline and Rehabilitation Solutions Part 1. This is the first in our new three-part webinar series. Presenting today is Heba Ahmed, whom I'll introduce shortly. My name is Liz Bouchard and I look after marketing for Armtec. My group runs Armtec's webinar program and I'll be your host for today's event. We are now offering our webinar through Zoom. We look forward to taking your questions at the end. Simply enter them into the chat box at the bottom of your screen at any time. Please also keep your microphone muted throughout the presentation. Attending this session will qualify you for a 1-hour technical informal CPD credit. A certificate will be emailed to all attendees. I will start off with a brief introduction to Armtec. We are one of Canada's oldest and largest infrastructure companies supplying a range of steel and HDPE-based products, as well as stormwater management. We serve numerous sectors including municipal, forestry, transportation, commercial, retail, and residential construction. Armtec has over 30 locations coast to coast and is now part of the WGI Westman Group of companies. They are Canada's largest commercial user of steel in Western Ontario and have over 1,500 employees. Presenting today is Heba Ahmed. Heba has over 19 years of experience in the infrastructure industry, holding different positions over the years from design to project management and sales leadership. She is a licensed professional engineer and sits on several technical committees. I will now hand this presentation off to Heba. Welcome, Heba.
Thanks, Liz. Let me take a minute here to share my screen. Okay, good morning, everyone. I'm going to start with showing an outline of what we'll be discussing today. I'll first present a quick introduction on why and when Trenchless Solutions make sense to implement. Then I'll be discussing some basic concepts and definitions that are commonly used when talking about trenchless procedures. I'll touch on common tunneling and relining construction techniques. And then we'll dive into the details of the different profiles, shapes, and materials that are offered by Armtec in these types of applications. I will end my presentation by going over a few case studies, which I'm hoping will provide a lot of clarity on how these products are used in the field. And finally, we'll present to you with a summary of the selection criteria that you need to consider in order to pick the optimum solution for your next rehab project. So let's begin by saying that trenchless technology is a rapidly growing industry due to the many benefits it introduces over open cut excavations. So aging infrastructure in Canada is putting a huge demand on replacement and rehabilitation of existing structures. To give you an idea, more than half of Canada's infrastructure is over 40 years old, and also about a third of Canada's water infrastructure is fast approaching or has gone past its service life. So there is a huge demand that needs to be serviced with replacement or rehabilitation that are potentially worth billions of dollars in project needs. So some of the main issues that are faced when considering open cut installations include things like obtaining the proper permits for the installation, which could be a lengthy process. Coming up with a plan to maintain traffic is probably the biggest headache when dealing with open cut installations, as you're going to need to reduce or reroute traffic, which is often required and becomes a huge inconvenience to commuters, causes a lot of disruption to local businesses and whatnot. Also, when excavating for a replacement, you're disrupting the road surface, which will affect the pavement quality in the long run. And of course, one of the biggest factors to consider is the potential high cost of excavation and hauling the material in and out of the site. In our experience, we found that depending on the reline material that you select, typically a rehab project can cost anywhere between 10 to 50% compared to the cost of an open cut installation. So just to give you an idea or a benchmark to the cost aspect here. And also another factor to consider is the impact to the local environment. Obviously, there's a lot of dust, silt, and other contaminations caused by vehicle emissions that are produced in open cut installations. And last but not least, worker safety is a big one here. Obviously, there are greater risks of falls, injury associated with digging a deep trench and working in it, as you can see on the left photo there. By contrast, as you can see on the right-hand side here, many of these factors are naturally eliminated with a trenchless installation, since all of the work is done from outside and without disruption, safety concerns, or any of the added cost encountered with an open cut installation. When we speak of failing pipe, we're typically looking at the 3 R's: repair, rehabilitation, and replacement. You can go with a mild repair, which in most cases is just a patch job that prolongs the life of the structure for a few more years. If rehabilitation is chosen, it can be done in several ways, and there are different materials shown here on the right-hand side that can be used for rehabilitation, and we'll get into that in a greater detail in a bit. Alternatively, you can replace the structure altogether, which can be done in either a conventional open cut construction or using a tunneling method. So first I'll talk about one type of trenchless operations, and that's tunneling. Tunneling is a subsurface excavation that we see commonly in applications such as linear infrastructure and mining. An example would be constructing mine portals or creating conduit excavation under high embankments. And these types of structures can be constructed using different types of materials. These materials include steel liners, which are segmental structural steel plates that are utilized in tunneling applications. I'll talk a bit more about this technology as we go on. Also commonly used are precast liners, and these are used in large boring operations. They're quite common for these types of installations. And then more traditional methods such as sprayed concrete, commonly known as shotcrete, as well as pipe jacking, which is used for tunneling operations as well. So tunneling is basically trying to get from one point to the next through the ground in a new excavation. The tunneling process itself is typically a staged excavation and follows these 4 steps outlined here. First, you excavate the tunnel based on the allowable soil conditions, and that's an important factor to consider when you're doing tunneling, is to really understand what the soil conditions are like. Once the tunnel is partially excavated, then you advance the rings of the liner as you continue the tunneling process, ensuring obviously that worker safety is maintained. Then the last piece of the puzzle here is to insert flowable grout or concrete, which is poured to fill the gap between the existing structure and the new tunnel segments. This step is crucial to ensure that all the gaps are filled so that the loads are adequately transferred to the new structure. It is worth noting that soil conditions are key, as I mentioned earlier, in determining the material suitable for the tunneling operation, as well as determining how much material you're able to excavate safely before installing the liner. Therefore, we highly recommend that a geotechnical engineer is involved, and the engineer will basically help determine these factors in a more effective and efficient manner. Also, since this is a very specialized type of construction, it is highly recommended that you also incorporate a contractor with previous experience in tunneling operations. Here you can see some old photos showing a tunneling excavation using the stage process we just discussed and utilizing steel liner in the process. On the right, you can see the workers excavating the tunnel using some hand tools in a staged manner and installing shielding before they proceed with installing the rings as they advance through. On the left, you see the steel liner plates are installed and in place and ready to be grouted in. And generally, when considering soft ground tunneling, as in the examples in these photos, the size range that we found is most cost effective is in and around the 42 to 60 inches in diameter. So that's really the sweet spot in terms of cost. We can do larger sizes. However, this is the most optimum size range for cost efficiencies. I want to mention that tunneling is not only done in a horizontal installation, it can also be done vertically. So you see the examples on the slide here showing a couple of photos of vertical shafts. And vertical shafts are quite common. They're basically installed in much the same way as the horizontal installation I mentioned. You can see here that the crew digs out the soil and progresses the tunnel rings downward to install each ring as opposed to inward. And here is an example of a vertical shaft. This one here is 32 meters in diameter, and it's constructed with steel tunnel liner plates that were reinforced with wide flange beams at every other ring. So each ring here is 0.5 meters. So basically every meter or so there is a wide flange beam to act as reinforcement to the steel rings. So there is a wide range of applications with steel liners, as you can see. And the second trenchless concept I want to touch on is relining. Relining can be done to provide either a full structural reline that takes on all of the loads, or can be used to create a facial restoration just to prevent further deterioration of the existing culvert. So it's important to understand the conditions of your existing structure and what type of relining is required for the job. So when the existing structure is completely deteriorated or failing, a full structural reline will be required. Whereas if the structure is experiencing some sort of cracking, spalling, or corrosion, you may only need a facial restoration of your structure just to prolong the service life of the structure. The construction sequence for relining installations can be done in one of two ways. The first is called the slip lining technique, where the new structure is pre-assembled on the outside of the hose pipe and then slid into place via some kind of sliding mechanism. The next step for that procedure is before grouting, you've got to brace the structure adequately against the hose pipe using some 2x4s or bracing posts. Just to prevent the liner from floating during the grouting process. The grouting process basically applies a lot of fluid pressures on the liner that can cause flotation. So it is really important to ensure that the bracing is in place before you apply the grout. And again, pumping the grout in the gap between the new and the existing structures ensures that no voids are existing and that the liner performs as a structural reline. A lot of the structures that Armtec provides, we design those structures in-house, and in most cases, these are designed as structural relines. So we really assume that the existing pipe or the existing structure has no more capacity remaining in them, and that the new liner or the new structure is designed to take on all of the live and dead loads that are applied to the existing. It is somewhat of a conservative assumption, but since we don't know the condition of the existing structure, we'd rather err on the safe side there. The second technique used is an in-place installation of the liner. For that to be feasible, the liner product needs to have some sort of flanges that facilitate bolting of the plates from the inside of the hose structure. Either that, or it has to be a wound in place or sprayed sort of solution that you can apply in place. So other than the variation in the first step, the rest of the installation steps are pretty much the same as slip lining, so I'm not going to repeat that. Here are a couple of photos of project examples using a slip lining technique that I mentioned. And here we are using a product called UltraFlow, which is a spiral ripped steel pipe that Armtec supplies. I will provide more detail on this product later on, but here you can see in the photos that the UltraFlow segments have been pre-joined on the outside using steel couplers. And on the right, you see the photo showing some pre-installed screw jacks, which are factory installed and are utilized here to help align help align and brace the pipe against the hose structure. So that way you can maintain the proper alignment and ensure that the pipe won't float. There are several different techniques of applying the grout, which will depend really on the length of the structure as well as the size. And here in this picture shows one of those techniques. Here the grouting process taking place from the inside, and the crew are feeding their grout nozzles right into these shop installed grout ports to pour the grout into the voids. So these grout ports are just threaded couplings that are shop welded to the steel liner. And then a threaded plug is also supplied to eventually close off these ports. Some may argue that the grouting process is the trickiest part of the installation. So this step must be planned for and designed to suit each project. The contractor needs to ensure that each lift of grout is allowed to fully cure before the next lift is poured. It's also very important to monitor the grouting procedure and ensure that all the gaps have been filled before proceeding to the next lift. As mentioned earlier, support is required in order to prevent the pipe from floating during grouting, and this is normally achieved through vertical bracing set through these 3-inch ports and propped against the host pipe at the 12 o'clock position. But as I mentioned, there are different techniques to do this. This is just one way of doing it. And grouting lift heights are determined based on the composition of the grout and the size of the structure. So the first lift is the most important to control and will probably be the smallest pour height. So we really recommend that you pay attention to that first lift as much as possible to ensure that the pipe is set into place and to prevent any flotation forces. We also recommend that the grouting material is flowable with very low strength. So around 1 to 2 MPa is what we find is used in most cases. And also the material needs to be very viscous with a minimum slump of 250 millimeters in order to prevent buckling of the liner plate. And keep in mind that weather, pumping equipment, and cure times will vary. So it's always best to speak with a knowledgeable supplier of grout material or cement material. They often have suggestions on the optimum grout mixture that will make the job easier for you. So now that we've covered the basic concepts, I'll go over some of the product details that Armtec can provide. And here you can see that the screen is split up between steel and plastic. On the left side are all of our steel offerings for this type of application, and on the right is the plastic offerings. So starting with the left side there, you can see some of our segmental steel products include multiplate, bridge plate, and a 2-flange tunnel liner plate. Also, UltraFlow, as I mentioned earlier, is a product that is commonly used in relines for smaller diameters. On the right are some of our plastic offerings, including Boss 2000 pipe, which, if you're not familiar with, this is a CSA certified HDPE pipe that is offered up to 900 millimeter diameter. Duramax is a steel reinforced high density polyethylene pipe that extends the diameter range up to 3 meters. A2 liner is a PVC pipe product that is used extensively in storm and sanitary relines. So the joints are rated for sanitary when used in that application. And SPR, or spiral wound pipe, is a new technology that Armtec has added to its product portfolio recently. And it is also an HDPE product that can be installed in place. So that product is actually ideal for in situ type of installations during live flow, and that will be covered in future webinars. But today I'm going to focus a bit more on the left side of the screen here, all of our steel offerings. And in future webinars, as I mentioned, there will be more detail on the Duramax and the SPR products that are shown here. So we're going to start from small to large. With that, the first product being suitable for size ranges between 450 millimeters up to 2600 millimeters. And this product is the UltraFlow product that I mentioned earlier. Again, it is a spiral rip pipe that lends itself really well to rehabilitation applications, mainly due to its superior hydraulic quality. It has a Manning's N of 0.013. And it also has a ripped profile on the outside that measures 19 millimeters and provides the structural stiffness required to support loads. So the profile really works to support some predetermined heights of cover that can be found on our brochures. And obviously, a steel pipe will be accommodating higher heights of cover than it would, let's say, a plastic flexible pipe. So that's something to keep in mind when selecting the material for your next project. You can see that there's a picture here that shows a view from the inside showing the smooth interior of the pipe. And again, that kind of highlights the smoothness and the Manning's end that would come into play when you're talking about hydraulics. And just to show you an example of how this is realized, if you're lining an existing 1200 millimeter CSP with a smaller ultra flow pipe, obviously you are losing some end area, but we can actually achieve almost the same flow in ideal conditions by using a smoother inside for the pipe. So basically, while losing end area, the idea here is to minimize the hydraulic loss by going from a rougher pipe to a smoother pipe. The second product here is called Multiplate, and that product has a 6x2 inch corrugation, or in metric, it's 152 millimeters by 51. So basically, crest to crest is 152, and the depth of the corrugation is 51 millimeters. It's available in 5 different thicknesses, from 3 millimeters up to 7. And there are different coating options here. And as well as shapes and sizes. So for coating options, we can do galvanized or polymer coated, or both. As you can see on the picture here, I'm just going to go back for a second. You can see here that the invert of this pipe was polymer coated, while the balance of the structure was galvanized. In terms of shapes, we can manufacture this profile in different configurations and shapes, including both open bottom as well as full periphery structures. Municipalities often have short to medium span bridges needing replacement or rehabilitation, and Multiplate is a very economical option for that. For rehab applications specifically, Multiplate is often installed using a slip lining method to reline the existing deteriorating structure. And it is done obviously without any invasive procedures or without digging out the existing road. So it's pretty effective in these types of installations, and economical as well. This technique can be used obviously by municipalities, as mentioned earlier, to stretch out tax dollars and avoid road closures. So the next product here that I'm going to go over is called Bridgeplate, and it was developed in the late 90s, early 2000s. It's a true metric corrugation with the profile measuring 400 millimeters crest to crest, and the depth of the corrugation here is 150 millimeters. So as you can imagine, it is a much stiffer section, and as such can be used to construct much larger spans than its predecessors. These larger spans are constructed without the need for any special features, which would otherwise be required in the shallower corrugations. Similar to Multiplate, Bridgeplate is also available in 5 different thicknesses. And each plate is only 300 corrugations wide. So each plate measures 1200 millimeters in total. These wider plates allow for faster assembly times in the field, as you are using less bolts to construct the same length. And also the same coating options that are available for Multiplate are available here in this profile as well. So again, polymer galvanizing finishes. And the application-wise, very similar to Multiplate again, while maintaining larger spans, as I mentioned earlier. The last structural plate product I'll discuss here is called Tunnel Liner, and we'll spend a bit more time on this one here because it is a true lining product developed for both soft ground tunneling applications as well as relining. It lends itself really well to rehab applications because it can be constructed from the inside of the hose pipe. As you can see here, the corrugation is similar to that of Multiplate in terms of stiffness. So it's about 180 millimeters crest to crest, and depth is 52 millimeters. With the main difference here being that this product has 2 flanges, as you can see on the sketch there. These flanges are used to facilitate making the bolting connection from the inside. Also, tunnel liner is available in different thicknesses depending on the load demands, and can be designed to fit custom shapes, and we'll talk about that as well. A bit more detail on the plate configuration itself. Each plate is only 500 millimeters wide, so it can be easily carried by a construction crew member into the hose pipe without the need for any lifting equipment. And each plate is corrugated, curved, and punched, and then bolted together to form the desired geometry. The flanges you see here on the picture serve to avoid the need to access the other side of the bolting operation, as I mentioned. And for pressure grouting, we can fit these plates with factory supplied half couplings, the grout ports that you see here on the picture, which are used to facilitate grouting again from the inside. Design service life is a huge concern when it comes to the design of steel structures in general. And it's important to note that there are several coating options available for providing the different DSLs. So the choice of the coating would depend on the environmental parameters found at the job site and the required service life, of course, which is now a requirement in the CHBDC code. So for any buried structure, there is a requirement now in the code to design for a certain service life. All of the coating options are outlined here, as you can see, and starting from left to right, there is the galvanized option, which provides normally a service life of 50 years. Next is the polymer coating, which provides 75-year service life. And finally, there is also a true aluminum product in tunnel liner plate specifically, and that is a marine grade aluminum that provides service life of in excess of 100 years. So this type of product is actually lighter in weight because aluminum weighs less, and obviously that's an added benefit to the constructability of that product. But also aluminum is an ideal material to be used in seawater or brackish environments. So this specific product is used quite extensively out east. A bit more on the customization of this product. We designed for different geometries, as you can see here, shapes and sizes, including round structures, but also box culverts are made possible with this configuration. So you can see here in the pictures, liner plate was designed to have a box shape, so it lends itself really well to rehab of existing concrete or cast in place box culverts that are deteriorating or reaching the end of their service life. And we can customize the shape so that we can create something that matches the existing very, very closely, obviously, to minimize loss of end area, especially when we're talking about water conveyance structures, but also while keeping a little bit of room to allow for the grouting operation in the void there. More custom shapes examples you can see here includes pipe arches, underpass shapes, horse shoe shapes. So there's a lot of different structures that we can provide here. We do have a set of standard shapes that are listed on our brochures, but we can also customize it based on the conditions of your existing hose pipe. I've compared the profile of tunnel liner plate to that of multiplate, mainly because they have very similar section properties. But you can conclude that these two products will offer the same kind of capacity in terms of load demands. The main difference that one has one has against the other is that the multiplate product has to be pre-assembled on the outside and then pulled into the hose structure, while the tunnel liner plate, as I mentioned, you can see on the right-hand photo here, the crew are working on the inside, building the structure plate by plate. So that's really the main reason between the two products. Otherwise, they're very comparable in terms of size ranges as well as loading capacities. I want to mention that the material spec that governs all of the profiles I outlined here is the CSA G401. So that material spec will cover fabrication, tolerances, inspection, repair also is covered in there, as well as the different coating options. And that can be downloaded on the CSA website. As far as design goes, basically as the physical size of the culvert increases, the structural design is required to be in accordance with the bridge code. So in Canada here, the Canadian Highway Bridge Design Code, or CSA S619, is accepted across the country. So the 19 version was issued recently in November of last year, and basically that's the governing code for across Canada. And the bridge code here demands that structures greater than 3 meters in span be designed in accordance with Section 7 of the code, which is titled Buried Structures, basically treating them as buried bridges. If you're considering a structure under 3 meters in span, these can be designed using AASHTO or ASTM codes, which follow the theory of ring compression. So basically, bending forces or bending moments are ignored in structures less than 3 meters in span. An extensive research was founded by the American Iron and Steel Institute in the late 50s and 60s on the theory of rim compression. And this method is now detailed in the Handbook of Steel Drainage and Highway Construction. The handbook can be downloaded on the CSPI website. And for tunnel liners, I also wanted to mention that AASHTO is used to perform additional checks on grout pressure and buckling of the liner plate, and also recognizes the in situ properties of the soils in tunneling applications. So if the application for these products is tunneling or relining, then AASHTO needs to also be utilized for these additional checks. Some common design challenges that we see on these types of projects include things like environmental concerns that stipulate or limit work to be done in the stream bed. So you see here on the left-hand photo, temporary planks have been run crossway between the existing footings to create a working bench above water level in order to elevate the work area and keep all of work outside of the stream bed. Other design challenges that we encounter includes accommodating bends, sags, and deflections of the existing structure. Those can be accommodated using some prefabricated elbows. So what we would do in this case is or ask the contractor to do a survey of the existing structure so that we can plan what sort of elbows and the geometries of these elbows that require to be manufactured and sent to site to accommodate the bends and the deflections in the existing structure. So just something to point out that these can be dealt with in that way. Arch on footing relines are common, and in many cases when relining existing open bottom structures, the contractor will need to build an extended footing in order to install the steel footing plates into and to ensure that the footing loads from the existing structure are adequately supported. So you see here steel footing angles are being utilized. These can be angles or channels and are usually supplied with the each order. These channels also come with anchored bolts that are L-shaped, and these can be either placed into the cast-in-place footing before pouring the footing, or we can also supply mechanical expansion bolts similar to the Hilti bolts that can be installed in pre-existing footings or precast footings. The longitudinal holes on the plates are in turn bolted to the long leg of the steel channel, as you can see here, to finish off that connection. And I also wanted to point out, there's a picture on the slide here at the bottom right-hand corner. I just wanted to point out that even with open bottom structures, a common application that we see in water conveyance structure requires that the structure be partially coated in polymer. So this is an example of a project where we only required to coat the footing plates on this arch in order to maintain the DSL required for this project. I wanted to touch on hydraulics, as this really comes into play when relining any water conveyance structure. And when considering hydraulics, we're really just concerned with the flow rate discharge from the structure and aim to minimize any hydraulic losses due to reducing the size of the culvert. So most of the time, slip lining projects come down to hydraulic capacity and whether that's going to work or not. We have found that in most cases, you can design a hydraulic option that will work to produce the same hydraulic capacity as before the culvert was relined. We just have to understand a little bit more about the conditions, the hydraulic conditions that we are considering for each project. So there are two main designs to consider, and each type depends on what controls the amount of water that can flow through the culvert. The first type is an inlet control culvert. This is where the capacity of the culvert depends on the amount of water that can enter the culvert. So with inlet control, water can flow through and out of the culvert faster than it can enter. Therefore, discharge or capacity is influenced by the size, the inlet geometry, and the headwater elevation. It is not, in this case, influenced by the roughness of the pipe. So when we're talking about inlet control, Manning's end really does not matter in this case. So oftentimes for inlet control to improve the hydraulics, we would need to design a more efficient end treatment, such as a beveled end or a mitered end that will allow more water to enter in the culvert. In outlet control, the culvert capacity is now influenced by energy loss. So that is because water can enter the culvert faster than it can flow all the way through. These culverts are usually characterized by low velocity and they're over flatter spots. So friction and slope are now factors that influence the capacity of an outlet control structure, in addition to tailwater elevation, geometry, and length. So now you can start worrying about things like Manning's end or roughness of the pipe when selecting your reline material. So we'll get into a little bit more on project histories or past projects that we've done, just to illustrate the concepts a little bit better. So the first case study I'm going to go over here is that of a triple reline located in northern Vancouver. The pipes that were installed were 1200 millimeter diameter ultraflows, and there were a number of challenges on this specific site. As you can see, the existing pipes were very old and definitely in need of repair. But being in an older urban area, open cut excavation was not a possibility. There are also other challenges here, including hydraulic capacity. Obviously, anytime you're reducing the size of the pipe, you're sacrificing hydraulic capacity. So here, the engineer actually designed a beveled end on the inlet side of the existing concrete head wall to improve the hydraulic performance of the reline and compensate for the loss end area. So as you can see here, there was an existing concrete head wall, so the beveled end was designed into the existing head wall to facilitate or to realize the efficiencies required to maintain hydraulics on this specific project. And here you can see a picture of the finished project. Overall, a very successful reline in an urban area. This next project was an application that warranted a sort of a hybrid method of installation. So we used both tunneling techniques here as well as relining and you might even say a new installation. This project was installed in the late 90s. It was under Highway 24 near Spiritwood, Saskatchewan. And since the road above was a very busy main corridor through Western Canada, disrupting traffic again here was not an option. Also, the culvert was under about 8 meters of cover, so it was very cost prohibitive to dig out this much in terms of the existing embankment. So the ministry opted for a trenchless installation here to keep costs low and reduce disruption of traffic. They basically implemented an area with a low speed zone, but kept the road above fully functional and operational during the entire installation. Some of the main challenges for this project, the existing 1600 millimeter diameter CSP was failing and had huge deflections in it throughout the length. These were braced in place to prevent any sudden failures of the existing structure. So as a result, this was an emergency culvert reline. It had to be done in a very short construction window as there was fear of the structure failing at any point. After performing the hydraulic analysis, the ministry also determined that the culvert required a significant increase in hydraulic capacity. So they deemed that the existing size was not adequate to service the hydraulics that are required on the site. So they needed to extend also the inlet and outlet in order to accommodate flattening of the embankment slopes. So you'll see a few more pictures that can illustrate this a little better. So Armtec proposed a solution incorporating two materials here. So the first material we provided was a 5x1 corrugated CSP sections. Those were used for the inlet and outlet extensions. And we also supplied a tunnel liner for 1200 millimeter diameter liner plate to reline the existing structure. The contractor first proceeded to cut into the existing embankment as much as they deemed safe, just to expose the ends of the existing structure. They also cut away some of the existing CSP that was deflected beyond repair at those outlets and inlets. Then the crew proceeded to install the new CSP pipe that was supplied by Armtec. They started basically on the downstream end while lining up the invert with the invert of the existing structure to maintain the proper alignment. Once the CSP portion was installed and backfilled, a transition piece was installed to connect the CSP portion to the tunnel liner plates. This transition piece, as you can see here, was made of one ring of tunnel liner plate that was shop welded to one complete section of CSP. And again, this was fabricated in the manufacturing plant and shipped to site so that we minimize the kind of the amount of field welding done on this project. And once the transition piece was in place, the contractor proceeded with tunneling through the embankment as they deemed safe by the soil conditions, and proceeded with installing the tunnel liner plate in a plate-by-plate fashion across the circumference. And you can see here on the right-hand photo, they're using some pry bars to align the holes on the plate laps. The bottom left-hand picture just shows you the extent by which the existing CSP was deflecting. So you can see there's quite a bit of deflection here that was braced along the length. And as you can see in the soil that shows on the interface here, they found 2-foot rock boulders that were part of the backfill material. You can also tell by looking at the backfill material that it wasn't very granular in nature. So we can conclude from looking at this that the cause of the deflections were improper backfill to begin with. On the right side, you see a picture of the crew cutting into the existing CSP at the interface between the old and new installation as they moved ahead. So here the contractor was prepared to use shielding for the soil interface, but since this installation was done in the cold prairie weather, they benefited from the soils being naturally frozen. So that helped quite a bit in stabilizing the soil during the tunneling operations. It's an added fringe benefit to working in cold conditions. And once all the plates were installed, the crew proceeded with feeding the grouting nozzles into the existing grout ports here and started applying the grouts in lifts. They did this in 3 lifts in total. And you see here the bottom picture shows you an inside view of the tunnel liner installation more towards the upstream end after the structure was fully grouted. And here's a picture of the finished product, completely grouted in and backfilled. Next, this project highlights a Reline solution for a much larger structure. This MTQ project required an innovative solution to upgrade a deteriorating concrete river crossing structure near the town of Tourville in Kamouraska. And the existing bridge was in very poor condition. The concrete was basically crumbling to the touch. There were a number of challenges with this one as well, namely the proposed solution needed to minimize any further damage while maintaining a safe working environment for the construction personnel. So again, there was a requirement to propose a solution to make sure that that's addressed. The deep fill situation on this project also presented another challenge where the replacement was a very cost prohibitive solution. Also, the large span of the existing structure, which was around 9 meters in span, basically narrowed down the options as far as relining solutions available for this size range. The structure was located in a remote area as well, so there was limited access to the site, and that enforced another requirement on the project that all materials and equipment required for this project needed to be easily transported to the job site, and obviously economies came into play here as well. Armtec proposed to rehabilitate this structure using a 5 mil thick bridge plate arch that spans 7.8 meters. This span was designed, it's a custom span that allowed a little bit of room on each side for the grouting operation. And this solution provided significant cost savings versus a new bridge installation, as this was basically the bridge plate components are very modular in nature and can be nested and shipped on trucks to site in an economical fashion. Here the contractor chose to pre-assemble 2 full rings of bridge plate on the outside of the host structure. So the segment that was pre-installed measures 2.4 meters in length, and then those segments were pulled into the existing structure, as you can see here. The plate insertion phase took only a few days to complete, so this was an accelerated project sequence as well. While the pre-assembly was commencing, there was a second team that was in charge of constructing the footings on the site. And once the concrete footings cured, the pre-assembled sections of the bridge plate were inserted by sliding them onto this polyethylene band that were specially installed in the concrete footing slots. So here there was a slotted footing design that incorporated these polyethylene bands for basically to reduce the friction between the materials while sliding the pre-assembled sections. And as you can see, the crew used these cables that were fed through eye bolts to pull the structure in with a medium-sized excavator. So they didn't really need any heavy equipment to do the installation here, as the weight of the structure and the cabling system was sufficient to pull these sections into place. Since the existing bridge spanned an environmentally sensitive waterway, diverting it or interfering with the riverbed was also prohibited on this job. So again, the contractor had to build up a working platform to keep all the work outside of the stream bed. So you can see the elevated footings here and the workbench that was built above the stream bed. Also notice on the picture here the close fit achieved with keeping the gap between the host structure and the bridge plate reline to a minimum, while allowing enough room for the grouting to take place. And here is a picture of the finished project. There was cast in place head walls and wing walls poured for an end treatment of choice here, and it's basically this is how it looked like in the end. So just to summarize, Armtec can provide a wide variety of products that can be used in rehabilitation applications. However, the material selections will primarily depend on these factors here. So first and foremost, the size range you're looking for, the shape, whether it's open bottom or full periphery, as well as the applied loads versus the strength of the material. Hydraulic considerations are amongst the top selection criteria in water applications and may dictate a material with lower Manning's N when the culvert is operating under outlet control, as mentioned earlier. And to adequately design for service life, durability comes into play, and you'll need to consider specific environmental parameters at each site, such as pH levels, resistivity, as well as abrasion if abrasion comes into play. Also, constructability will dictate what method of installation is feasible. So in some cases, you'll have property line constraints that will eliminate some of the options available to you. Those pre-assembly or slip lining techniques might be prohibitive if you have these constraints or restrictions. And also sustainability is becoming more and more common with DOTs and municipalities. You may be required to stay within a certain environmental footprint limit during the duration of the project, so something to keep in mind. And if you do require an EPD for the products that were supplied from Armtec, we do actually have EPDs that we can present and the procedure by which we determine those sort of equivalent to lead points that are published on our website, as well as the Corrugated Steel Pipe Institute's website. And finally, cost. That's always a big factor, as normally budget constraints are top of mind. And cost-benefit analysis can demonstrate the final score when considering replacement versus rehabilitation. So before we move on to the question period, I just wanted to put this slide up and highlight some of the values or the key factors affecting your selection criteria. You can see in the table here an outline of each product, the material type or the coating, as well as the associated design service life. You can also see the Manning's N values are listed here for the different products, as well as the different size limitations for each product. So all this information is found on Armtec's product brochures, which can be downloaded on our website. But again, also our Armtec teams, our sales reps are available if you do have any questions about these products. So with that, I will hand it back to Liz and we can start taking some questions.
Okay, Heba, thank you for your presentation. And thank you for joining today's webinar. We hope you enjoyed it and found the information valuable. Our question answer period is coming. Please continue to submit your questions using the chat icon at the bottom of your screen. Okay, today's webinar is the first of a three-part series. We hope you enjoyed it and will stick with us for upcoming events. Our next Reline and Rehabilitation webinar will focus on the use of steel reinforced polyethylene pipe. To stay informed, please stay connected with us. You can follow us on social media, on Facebook, LinkedIn, and others. And now we'll move on to the question and answer portion of the presentation. So Heba, first question. Why does the grouting have to be staged?
So when we choose a certain material for the reline or the tunneling application, each material will have certain section properties. And part of the design process that we do, one of the cases of designs we look at is the fluid pressures that are applied as a result of the grouting process. So to minimize buckling or to eliminate buckling of the plate, and again, depending on the size and the section properties, there is a limitation on the lift size of the grout that and a certain pressure that the material can take before it buckles. Therefore, we dictate those limits in each grouting lift to the customer in order to make sure that those are maintained.
Okay, and moving on from there, second question, does Armtec provide the bracing and supports during grouting to prevent the pipe from moving?
So Armtec is a manufacturer of the liner material. So as such, we do not provide any construction bracing or equipment or anything that the contractor normally does. That's really the contractor's scope, not the manufacturer's scope. So in terms of bracing, typically what we found the contractors use is what they have on hand or what they can readily order in terms of bracing materials. Sometimes they just use simply 2x4 planks there or anything else that they can source.
Okay. Another question here is asking if our Reline solutions are fully structural solutions or do they rely on the strength of the host pipe?
So as mentioned earlier, that depends on the intent of the reline. So part of proposing a certain thickness is what kind of loading do we have to support. So if the structure is not meant to be a structural reline, and if it's just a facial, like a facelift of the existing, then it'll probably be a lighter gauge. If, however, the contractor or the consultant has deemed that the existing structure is in failure mode or is in danger of failing, then a structural reline will need to be implemented. And in that case, we will design it to take all of the loads and the liner will be probably a heavier gauge structure.
Okay. Should the outlets of the rehabilitated system be finished in a specific way?
So End treatment is really, really important, especially in water conveyance structures or culverts. And it has to be planned adequately depending on the site conditions, depending on whether the culvert is an inlet or outlet control. It comes into play when we're talking about hydraulics and flow output as well. So with all of that being considered, the proper end treatment needs to be selected. And there are different options depending on the situation, but some of it can be a sort of a concrete head wall or a mitered or beveled end. So there are different options, but it really depends on the situation.
Okay, great. So we have time for one more question. We'll wrap it up with this one. Can your company provide site support for when these projects get constructed?
So it depends on the scope of the project. In a lot of cases, the scope is just for Armtec to be a supplier on the job. But if there are some requirements to provide site support, Armtec definitely has adequate coverage throughout the country. We have our different we have region engineers positioned in the different provinces that can be mobilized to go and assist with the assembly and backfill operations, just sort of to provide some guidance. But it does have to be defined clearly in the scope and in the type of order that we receive.
Okay, thank you, Heba. That's all the time we have left for today. As you learned in the presentation, there are many applications for Reline and rehabilitation, and Armtec can help support you through the selection and design process. Feel free to contact us at any time for assistance. Thank you.